not saying something. Am I recording? How can I tell if I'm recording? Anybody know?
We got a notification that said that you were recording.
Huh. Check this out, David.
Top left corner on my screen.
Top left corner. I don't have that. I wonder if it's because I'm sharing. Hold on, let me try that. I'm gonna experiment. Stop share. Yeah, now it says that I'm recording in the top corner, but when I share my screen, it must just be like, you know. Okay. So two events are mutually exclusive if they can't occur in the same moment in time. Maybe I'll switch pens. This seems far too bright and cheery for such a tired day. Tell me how you guys felt about having Friday off.
It was really strange.
Wasn't it? Especially after having Thursday. I don't know, maybe the roads were really icy. I didn't go traveling on Friday, so I guess I don't know. Anybody actually tried driving on Friday?
Yeah, they were fine. Not like Thursday was really bad on the road, so it was like weird.
I was really freaked out about driving home on Thursday. It was bad. It like, normally my drive home takes me a little over 20 minutes and it took me like almost an hour. Okay. So event A is randomly selecting a blood donor with type O blood, and event B is selecting a female blood donor. So can you get both of those in the same sample? Yes, so that means it's not mutually exclusive. Everybody always messes that up. They want mutually exclusive to be the one where it could happen at the same time, but it's the opposite. All right, how about selecting a jack and selecting a face card, mutually exclusive or not? Should be not mutually exclusive. And that is because a jack is a face card. So just in case you're wondering, on the AP exam and in my class, every time that they talk about a face card, they're talking about a card with a face. So that would be a jack, a queen, or a king. I know aces are also high, but they don't count. Okay, so there's the addition rule. Probability of A plus probability of B minus the probability of B and, or A and B, otherwise known as the overlap. So if it's the probability of A and B, you multiply. But it's the probability of A or B, you add. And then subtract the overlap. Okay. So I'm going to do A and C, and then I'm going to give a prize for B and D. So let's do A. A dice is rolled. Find the probability of rolling a 6 or an odd number. Okay, so you see how it says or here? That means I'm going to do two things. I'm going to add something and subtract something. Okay, so probability of rolling a 6 is 1 out of 6. And the probability of rolling an odd number is, let's see, there's 3 odd numbers, right? 3 out of 6. So on this down here, I'm going to say, well, this was a 6. This is odd numbers. So that's a 1, a 3, and a 5 Do we have any overlap there? Are there any odd numbers that are also a 6? No, so we're going to subtract nothing. Gives you 4 out of 6. Michaela, are you just watching?
No,
You're taking notes?
on some of them.
Okay.
Can I get the notes from you when I come in?
Yeah.
Like that just works better for me. I don't have a printer.
Sure, as long as you're trying some of the stuff in front of you too.
Okay.
All right, C, use the addition rule to find the probability that you roll two, when you roll 2 dice, you'll get doubles or a sum of 8. Okay. All right, so here's our doubles, and here's sum of 8, and here's the overlap. So let's see, if I get doubles, I could get double 1s, double 2s, double 3s, doubles, double 4s, double 5s, double 6s. That's 6 out of 36 choices. Does everybody remember why it's 36 choices? Because 6 times 6 for the 2 dice. Okay. And then we also need to think of things that add up to 8. So let's see, we've got 2 and 6 and 6 and 2. Those add up to 8. And you could get a 3 and a 5 or a 5, 3, and those would add up to 8. Or a 4 and a 4 would add up to 8. That's it. I can't write 1 and 7 because there's no 7 on a dice. So that's 5 out of 36 here. Then what's the overlap? What in here did I count twice?
4s.
Right. So that'd be an overlap of 1 out of 36. So 6 plus 5 is 11, minus 1 is 10, 10 out of 36. Same thing as 5/18. And remember, on the AP exam, you can either have a simplified fraction or to 3 decimal places when you're talking about probability. All right, you try B and D for prizes. I put the answers next to the problem so you can check and see if you're right. And then we'll have somebody share. Okay, go ahead and raise your hand if you have an answer for B or D that you want to share. Or am I not giving you enough time? Looks like all of you are still working.
Miss Nussbaum,
Yeah?
my screen is like going black.
Oh, that's fun. When's the last time you actually restarted your computer?
I turned it on normally this morning.
Well, that's not good. Try restarting it and come back to the conversation. All right, are we ready to go over it, guys? So raise your hand if you want to share for B or D. Either one. Hey, Mitchell and Krista. Are you guys not in a competitive mood today, or are you not understanding this stuff very well?
I'm just working on it a little bit more.
Okay, Krista?
I was just having trouble with B for some reason. So
Okay. Well, let's talk about it together then. Megan, do you want to take B or D, and I'll take the other one?
I'll do D.
Okay. All right, I'm gonna do B first then. So card is selected from a standard deck. Find the probability that the card is a face card or a heart. Ooh, maybe I got it wrong. I bet I got it wrong, guys. No wonder you're confused. Face card or a heart. Okay. So that would be, let's see, face cards. I don't want to take it away from somebody because I feel like somebody's going to be able to get it now. So that'd be more like 22 out of 52. Okay, somebody want to do that one then? Mitchell, you look like you want to. Yeah? Okay, do it.
So there is 12 face cards.
In a deck, because there's like the jack, queen, king of all four suits. Yep.
There's 13 hearts,
Mm-hmm.
and then there's 4 hearts that are face cards. I mean 3 hearts that are face cards.
So like
And
this
then
would be specifically like that jack, queen, and king of hearts.
Mhm.
Okay.
So then when you add that all up, it equals 22 out of 52 or 11 out of 26.
Beautiful. 11 out of 26, yep. Okay. Next up, we've got a probability of a sum of 7 or a sum of 8. Megan?
Okay, so you'll do, so there's 6 things that could be out of 7, because it's like 3 and 4, 4 and 3, 2 and 5, 5 and 2, 6 and 1, and 1 and 6. So there's 6 different choices there. And then you add that plus the things that could be 8. So there's 2 and 6, 6 and 2, 4 and 4, 3 and 5, 5 and 3. So that's 5 out of 36.
Yeah.
And then you don't, there's nothing that overlaps because nothing can be the sum of 7 or the sum of 8 and the sum of 8. So you do 11 over 36.
Brilliant. Nice job. No overlap there at all because it can't overlap. Sorry, I messed up that one. Mitchell wants an I'm-a-winner sign, I assume. And Megan, is there another animal that, since you seem to really hesitate there, it seems like maybe there's another one?
No, I'll just take an I'm a winner sign.
Oh. Oh, were you debating between a duck and an I'm a winner sign the first time? Okay. You were like, well, I'm collecting those I'm a winner signs because I got to get that poster. And then you're like, oh, a duck for real. Oh, my weakness. Okay. So moving on to the next page. And I think after example 4 is where we're going to stop for the day because I want to do a whole day by itself on permutations and combinations. Because that's going to take a little while to understand, especially for those of you who haven't seen it before. Okay. This was Mitchell and Megan. All right, so why don't I just see if you guys can do this on your own? A blood bank catalogs the types of blood, including positive or negative. Its RH factor given by donors in the last 5 days. The number of donors who give each blood type is shown below. And this actually is a pretty good distribution of how blood types normally go. Anybody know their blood type in here? What's your blood type, Megan?
O negative, I think.
Wow, doesn't that mean that you can give to anybody?
Yeah, maybe.
You're a universal donor. That means that if ever there was an emergency situation, you could give your blood. I mean, I wouldn't personally like you just hand it to them or anything, but like you can give your blood to anybody and they definitely won't get sick. AB positive is a universal receiver. That means that they can get blood from anybody and they'll still be okay. Okay, so you need to find the probability that a donor has type O or type A blood. And type AB is not counted as type A blood, just so everybody knows. Here's what I got for them. Better now, Caitlin? Good. Give you a second to work on this. There's also an assignment in Schoology now if you want to drop your homework later today. Okay. Who's up for it? All right, Michaela and Krista, I'm giving it to you guys. So sorry, Megan, but you just keep on killing it. So let's let somebody else. Michaela.
Wait, I was gonna raise my hand.
Oh no. Well, if you're gonna raise your hand, then we have to do a thing. Okay, Michaela's 1, Krista's 2, Caitlin's 3. 2, which is Krista, and then Caitlin, 3. All right, Krista, you're up first.
Okay, so for A, you do 184 over 409 plus 164 over 409. And then that equals 348 over 409, which equals 0.851.
Okay, so this is equal to that. And tell me why there's no overlap with the type O or type A blood.
No one can have both.
Right, no one can have both. Even though technically having type AB blood means that you've kind of got both, but we're not going to consider it in that because if you have type AB blood, they just call it AB blood. So, Krista, animal, I'm a winner.
I'll take the cow.
All right.
Was there a cow?
There was a cow. Yes. There. That's your cow right there.
Okay.
All right. Caitlin?
Okay, so the probability that it's type B would be 45.
Mm-hmm.
And then you would add 65 because that's the probability for RH factor.
So that's
And
like
then
over here.
subtract the 8.
And 8 is having both. Okay.
And then it would be 102.
All right. Which is this. Nice job. So if you're trying to imagine it, envision right now that let's say that Caitlin had type B blood. And so when I was listing who the 45 people were, she was in there. But she also has Rh negative blood. So when I list the 65 people who have Rh negative blood, she's actually in both groups. And that means she would be in this 8 that I subtract because I counted her twice. Okay, Caitlin, chicken, rooster, goat.
Goat.
Good call. All right. Okay, guys, that's where I'm stopping for the day. We're gonna do permutations and combinations tomorrow. On your homework on this sheet, the homework's at the bottom. You can just do the first part. So only 5 problems today. I'm gonna wait until I see your homework uploaded before I let you go today, guys. So there is a Dropbox right now, so take your time, get it in. Tanner, I've got yours. You can go. I suppose I can stop recording.